limits. While evaluating definite integrals involving substitution, it is more convenient to change the limit of the integrals. So let's take a look at this now. While we solve this using algebraic substitution, we will say that let u be equals to 2x squared plus 7. Okay, and our du dx is equals to 4x, and our dx is equal to du divided by 4x. Now, let's consider the lower limits, and let us also consider the upper limits. So lower limits is x is equals to 1, and when x is equals to 1, our u is equal to 2 into 1 squared plus 7, which is 2 plus 7, which is equals to 9. And our upper limits, we have when x is equals to 3. And when x is equals to 3, u is equals to 2, 3 raised to power 2, plus 7. And this will give us 2 times 9. That's 18 plus 7, which is equals to 25. So when x is equals to 1, u is equals to 9. And when x is equals to 3, u is equals to 25. So we can now say this, that integral of x is equals to 1 and x is equals to 3 of 5x and square root of 2x squared plus 7 dx can be written in terms of u, and that will be u is equals to 9, because when x is equals to 1, our u is equals to 9, and when x is equals to 3, our u is equals to 25. And we make our substitution 5x, and we remember that we made u to be equals to 2x squared plus 7, and this will give us square root of u, and our dx is du over 4x. Now with this done, we can now integrate as u is equals to 9, u is equals to 25, and we'll be left with 5 over 4 u raised to power half du. Now since we are all now with the variable u, we can just simply say this is 9 to 25, or 5 over 4 u raised to power half du. Now this, after integrating this, we will be left with u raised to power 3 over 2 divided by 3 over 2 from 9 to 25. So now instead of substituting our u back, we can just go ahead to continue solving with u. So instead of saying this is equivalent to 5 over 4 into 2x squared plus 7 raised to power 3 over 2 divided by 3 over 2 from lower limits of 9 to upper limits of 25. Then we'll now begin to substitute our limits. We can just go ahead and solve with this. So going ahead to solve this, 5 over 4, this becomes 5 over 6, okay, with square root of u raised to power 3 from 9 to 25. This involves the application of the law of indices. So we have 5 over 6. Let's substitute our upper limit to be 25 raised to power 3 minus lower limit of 9 raised to power 3. And now this will go 5 over 6 into 125 minus 27. And simplifying this, we will have 81 2/3. Let's take another example for more clarification. Let's evaluate integral from 0 to 2 of 3x divided by square root of 2x squared plus 1 with respect to x. Now, definitely in this case, our u is equals to 2x squared plus 1, and our du dx is equals to 4x, and our dx is equal to du divided by 4x. So with that done, let's change our limits. When x is equals to 0 as the lower limit, our u is equals to 2 into 0 squared plus 1, and that will give us 1. And for the upper limit, that is x is equals to 2, our u is equals to 2 into 2 squared plus 1, and this is equals to 9. So this becomes our new lower limit, and u is equals to 9 becomes the new upper limit. Therefore, we can make our substitution of change of variable. That's when this is x is equals to 0, x is equals to 2 of 3x divided by square root of 2x squared plus 1 dx. It becomes, we are changing our upper limit and lower limit, and this one becomes u is equals to 1, and our upper limit becomes u is equals to 9 of 3x divided by square root of u, because we have made the substitution of u is equals to 2x squared plus 1, and our dx is now du divided by 4x. So when x nullify each other, we'll be left with 3/4 integral of 1 to 9 1 over square root of u with respect to u. So simplifying this further, we will have 3/4 integral of u raised to power minus half du from limit of 1 to 9. Now, since we have changed limits, we don't need to substitute our u back into this. So this reduces the stress in simplifying further. So let us integrate u raised to power minus half, and integrating u raised to power minus half, we have u raised to power half divided by half from limit of 1 to 9. So this gives us 3/2 of u raised to power half from 1 to 9. That is 3/2 with the square root of u from 1 to 9. So let's substitute our upper limit and lower limits, noting that the limit has changed from x to u. So we have 3/2 of square root of 9 minus square root of 1. And that is 3/2 into 3 minus 1. And this will give us 3/2 into 2. And our final answer will be 3. So change of limit reduces the stress in simplifying further after doing algebraic substitution. Now, since there are various forms of substitution, we have algebraic substitution, we have trigonometric substitution, and we have integration or reduction formula. And in our next series of video, we'll be dwelling on trigonometric substitution, integration using trigonometric substitution.